welcome all of you to this live session. And what we will do is we'll begin by taking up the questions. So, questions have been asked on the Google form. Let me just take them first, and then we can take questions from live comments. So, till this doubt, we had covered it in the last session. So, we'll start with Engineer Chinmay Sarkar. He is joining us from West Bengal, Alipurduar, and he is a working professional. So his question is how to calculate the FSC area of for doubly reinforced sections. We have to calculate the FSC, that is the stress in compression steel, and how to do that for grades F5, 550, and 600, and so on. So why he is asking this question is because let me just a minute. I'll just open this. So why this question is being asked? Because if you refer to the Indian standard, in the Indian standard they have given those XU by D values. I don't know if you know it or not. There are XU max upon D ratios actually given for different grades. And when you are calculating FSC, so when you are doing the doubly reinforced design, then you need those XU max by D values because where am I? Just a minute. Let me just share. Give me a minute. What I will do, I will have to. Uh, yeah. So that OneNote screen is visible, I believe now. And also, what I will do, I'll just copy that question from there and bring it over here. So, how to calculate the FSC for grades F5, 550, 600, and so on. So, why this question is being asked? Because if you know that when you are doing the doubly reinforced calculations for doubly reinforced beams, what happens is that you require this FSC value, that what is the compression steel, uh, that steel that you're going to provide in compression zone, how much stress it can take. So for that, you often have to use this ratio XU max upon D. Okay. And if you refer to the IS code, this XU max upon D is given only till FI 500. So till a grade of FI 500, you have been given this value, I guess equal to 0.46. Beyond this, you don't have the values. So now if you don't have the values, using similar triangles, you are unable to find the FSC value. So if you are unable to find that FSC value, because similar triangles is not applicable, because you don't know that XU max upon D ratio, so you won't be able to find the FSC using the normal process of similar triangles that we use. So that is his confusion. So yeah, it's an appropriate doubt. It's a valid and genuine query. And what I also do is that because this data is not available, either you go by the first principles, that means for each and every section based on the actual steel, you go by using the stress compatibility equations and then revise the neutral axis depths and go on doing that first principle compression equal to tension and so on to do it. But otherwise, you won't be able to find out the XU max upon D for different grades. We don't know these values actually. So in such a case, you are stuck. So what I do personally is that even if I'm using, let's say, FI of 550 grade, that's a practical thing that I do right now. That even if I'm using FI 550 and let's say my beam is doubly reinforced, then I still continue to take FI as 500, find out the reinforcement, and then provide the same reinforcement for FI 550 also. Okay, so that is what I do. So yeah, so as of now, we are restricted in the usage because we don't have those values with us as of now. Next question is by Mr. Harish Acharya from Udupi, Karnataka. He's asking what will be the design considerations when we have more than F60 grade concrete. So again, this is similar. So Mr. Chinmay was asking about the reinforcement grades that are not mentioned, and Mr. Harish is asking about what will be the design consideration when we have more than M60 grade concrete. So here the answer is easy. See, your Indian code tells you, uh, Mr. Chinmay, sorry, Mr. Harish is saying that beyond uh, M55 grade, there are no stress strain diagrams. No, I don't think so. That's not the case. I don't remember anywhere seeing beyond. So if you look at this IS code stress strain curve, nowhere it is restricting you to. So if you see, I have just copied that screenshot. So nowhere it says that you have to restrict or you cannot go beyond 55 grade. Okay. So I don't know from where this M55 provision is there. See, this stress strain curve is clear. So till this strain of 0.002, till this strain level of 0.002, you have been given, and at 0.0035 it's the limit. So your concrete strain cannot go beyond 0.0035, at which it can resist FCK, but of course we will reduce it to 0.67 FCK upon gamma m, and which reduces to 0.446 FCK. So at a strain level of 0.0035, this is the uh, stress level that you can have, and at level 0.002, till that level it is linear and then parabolic. So over here grade of concrete will not change anything as such. Okay, over here grade of concrete is not going to change anything as such. All right, so stress strain curve remains the same. You can use the same stress strain curve. Then uh, next question, another question from engineer Harish Acharya. He is saying how to calculate the time period for structures with cantilever. So see, for if your structure is having cantilevers, you should include it, because anyway you are not doing it manually, I believe. So you should include that cantilever, let's say, in your model. Okay, first of all include that cantilever in the model. Now for time period calculation, as per the Indian standard, we are forced to use the codal formulas only. We cannot come up with our or we are not allowed to use the computer model time period which we get from computer model. So we are forced to use the codal time periods. So now what you can do is you can apply the same 0.09 HO root D or whichever other formula is applicable. For tall buildings, now you have a different time period formula. So the applicable time period formula you use, okay, in that the D you should take in such a manner that it shall give you the lowest possible time period. That is when lowest possible time period means highest possible seismic SA by G value will come. So whatever is the possible lowest value of D that you should take up, and then, so by that I mean you don't include the cantilever span in that, because if you include the cantilever span in that, no, in fact, you include the cantilever span in that, because then your time period value will come down. That means SA by G will increase. So my suggestion is that, let's say if your building is like this and it has a cantilever like this, although your code does not specify in a cantilever what is the base width that you should take, but then you can take the judgment call, take the appropriate width, and then what you can further do is that separately you apply the vertical earthquake for this cantilever. So that will be important, that you apply the vertical earthquake for this cantilever, and then the procedure for vertical earthquake calculation is given in the code, so you can follow that procedure. So short answer is that time period you are forced to use the codal formulae, and so that those are the formula you have to use. You can make certain adjustment in this base width, although the code is not quite clear that if you have large cantilevers, what is the base width you should take. But you could make that judgment call to deliberately take a larger base width so that you get a smaller time period and a greater SA by G, or you could stick to the conventional base width definition, that is whatever is the ground coverage, whatever is the area coverage on ground, only that width you take. And forget the cantilever in time period calculation, base width, and then separately you do the vertical earthquake on the cantilever and then check it. Okay, all right. Then next question is from engineer Gulam Jilani. He is from Indore. He is a working professional. He is saying many clients in low cost project are not providing us soil report. Yeah, so this is a genuine doubt and this is a genuine problem structural engineers face, because these days even if you go for a single bore log, how much does it cost? Does anyone have any idea? Suppose I want to go for a one single bore log, okay, and let's say it is 6 to 8 meters deep, and uh, I'm using this bore log data for ascertaining the C5 values, let's say. So how much does it cost? Anyone has any idea? So minimum, I would say, even in smaller cities, it may cost slightly more because that bore rig has to be transported. But I will still say it will cost you around 25 to 30,000 per bore log. Okay, so that's a lot of cost if you see, isn't it? That's a lot of cost. So if you are doing a small project, 1500 square feet, small plot, and you are doing this and you are designing this, maybe your consultancy fees will be sometimes lesser than what a single bore log will cost you. So the client is not generally usually inclined to pay this sort of money to geotech consultant or to geotech testing agency, isn't it? So in such a case, what you can do is, first of all, you should have some prior experience of working in similar area. For example, if I were to talk where I live, there we know that till a certain depth we are going to get black cotton soil. Beyond that depth, we will start getting some yellow muram. Beyond that, at some locations we may get hard strata. At some locations, that yellow muram type of soil continues. So we know where we stay that in those regions we have to go for let's say after removing the black cotton soil, we can take up to 18 to 20 tons per square meter as our SBC. Okay, so you need some prior experience in that form, or what you can do is maybe you can go for some open excavations. So on your site, you can do some open excavations of around, let's say, 2 to 3 meter deep open pit, and that open pit you can investigate. Maybe you can collect those samples and then do some testing, so that if you collect that sample, disturbed sample, and then you go and do some testing, maybe that will cost you less than uh, undisturbed sample collection from site. So this open type of excavation you can do and then take a judgment, or take that disturbed sample and get it tested. So that those sort of things you could perhaps do. Okay, so either you have some prior experience of that region, or you do an open excavation, or you do nothing, just assume a basic SBC value and do that work. This problem is more in the northern plains where we don't have good soils. Uh, so that is a problem that engineers may face, mostly in the northern plains of India, from let's say Punjab to Bengal, even in Bangladesh, even in Pakistan, in the alluvial belt, poor soils are an issue. So there they have to be more careful. They have to go for piles, or they have to take a very low SBC. But yeah, These are the options you have. Yes. Any other question? Just give me a minute. Yes, please. So this was Engineer Gulam Jilani asking. Now, so these are the questions we have on the Google form. Now let me take some comments. So Engineer Islauddin is asking, column height is 15 meters, crane bracket level is 7 meters, mezzanine floor level is 3 meters. What will be the LY, LZ parameters in STAD? Column is having a gut spacing of 1.5 meters. Column is at gable end corner. Gable end corner. So I am assuming that this is your situation. You should, in such cases, you should try and share some supporting images also. So I'm assuming this is my plan. You're talking about this gable corner column. Yeah. And I'm assuming right now that column has orientation like this. Okay. This is my assumption. And let's say that local axis, if I had to draw local axis, this is local Y, this is local Z. Okay. I'm assuming this type of configuration you have. And now I'm going to draw the elevation of this column. So in elevation, my column is looking like this. And what he's saying, crane bracket is at, where is it? What he's saying, column height is 15 meters, crane bracket is at 7 meters. Okay. Crane, okay. So what I'm assuming that, let's say your roof is over here. This height is 15 and crane bracket is at 7 meter. This height is 7. Let's forget the mezzanine right now. Okay. Let's forget the mezzanine. So he's asking what are the effective lengths that we should take. So effective, and then there are girts also. So you have gird, and I'm assuming that these girds do have the flange braces, so that the other portion of this flange is also connected by that flange brace. So his question is, what is the LY I should take? So LY, you can take it as 1.5 meters in this case, assuming that your gird spacing is 1.5 meters, and assuming that the girds do have flange braces also. So assuming these two things, uh, I would say that LY in this case, you can take it as 1.5 meters. Now, if it's a gable corner, okay, the gut over here in the gable is slightly tricky. I mean, because you brought a case of gable corner, there will be guts over here also on this face, right? So again, those guts will also be at a spacing of 1.5 meters. But that placement of gut is slightly tricky. Now, some people will take in this case LZ also equal to 1.5 meters, because they will say that gut is also providing, I mean, the gut on the gable face is also providing support. So they will again take the gut spacing as the LZ. But I would still say that because LZ is a critical dimension for us, so in my opinion, you may not, or you should not rely on this gut over here, because tomorrow, let's say if this factory goes in expansion and they remove this face and then they continue ahead, then your LZ drastically changes. So my suggestion to you would be that you take the LZ as full height, 15 meters. Okay. Unless you have that mezzanine which has a proper supporting arrangement like this, then maybe in the lower portion where you have that mezzanine connection, you take LZ equal to 3 meters over here, and above that you take LZ of 12 meters. But if that mezzanine connection is not proper, you take that LZ as full column height 15 meter. Okay, so don't rely on the girth spacing which is going to be provided at gable end. That is my opinion. Although if that girth is there, you could always take that effect into LZ. But because tomorrow you never know, generally these gable ends may go into expansion, your shed may expand, and that's why this is my opinion that it is always better in this case. Because see, anyway you are not going to change the column size. For example, if you had a column over here, so suppose this is C1, this is C2, this is C3, and girths are anyway going to be provided like this. So for C3, you are going to take Ly of 1.5, Lz of 15. For C2, you are going to take Ly of 1.5, Lz of 15. And suppose over here I take Ly of 1.5, Lz equal to also 1.5. So are you going to change the column size because of lower effective lengths? Answer is no. You will you are obviously going to provide the same column size at gable corners also. So uh, therefore I said that I would still continue to take the same LZ as 15 meters and design this gable corner also. However, it was getting a support from the gable girts, and you could have taken LZ of 1.5, but personally I would continue to take LZ of 15. Okay, good. Then Engineer Rohit Patel is saying shear stress due to. Okay, so he had shared one query a couple of days ago where mostly what happens is that beams, if you do ETABS design, if you do ETABS design, then you must have observed this that many times the beams are failing in torsion. Yeah, beams are failing in torsion. I don't know if you have observed it if you are working on ETABS beam design. So in outputs, you often see this thing happening. Now, the reason generally is that this tau v exceeds tau c max. Now, when your tau v exceeds tau c max, what does your code say? What does your code say when your tau v exceeds tau c max? Then your code says that the only option that you have is to redesign. That means increase the beam dimensions because no amount of shear reinforcement is allowed for you to put over there if your tau v goes beyond tau c max. So you have to increase the beam sizes. What happens then is when you increase the beam size, you find yourself in some sort of a loop because when you increase the beam size, you will often notice that the shear stresses also increase. Correct? Have you observed such a thing happening? So it happens quite often that when you increase the beam size, because the stiffness has increased, so many times the shear stresses also increase, and still the tau v remains more than tau c max. So you should investigate this further. What is the reason why you are getting this tau v as a high value? Many times, many times the reason is many times the reason for this high tau v is torsion. So there is torsion in your beam. Okay, there's torsion in your beam, and that torsion in your beam, because we convert as per the IS code when we are designing for torsion. How do we convert the torsion into shear? So if I remember correctly, we have this type of formula. We yeah we 6 tu upon b, something like this. Okay, so what's happening then? We do this V by Vd to find out the tau e. So torsion, presence of torsion, and for small width beams, it is going to drastically or it is going to severely affect the tau v value. And when this tau v is high, your tau v goes beyond tau c max, and then there are these beams failing in torsion. So what you need to investigate is that why this torsion is coming. And if this torsion is a torsion of compatibility torsion, if the torsion is compatibility torsion, you can take this call and apply modifiers, torsion modifiers, and rely on the other design actions to take that compatibility torsion. Okay, so you need to first investigate whether your torsion is a compatibility torsion or an equilibrium torsion. How will you investigate it? By understanding the configuration. By compatibility torsion, we mean it means that if that beam is not able to take the moment, sorry, if that beam, so for example, if this is my section and this was the arrangement, and suppose this beam is not able to take the torsion, what will happen? The slab will, let's say, bend more. So the slab bending moment increases because this beam was not able to take the torsion. So this is a case of compatibility torsion. What is a case of equilibrium torsion? Suppose I had a cantilever without any backspan coming from this beam. Now, if this beam does not take that torsion, this cantilever is unstable. So this is an equilibrium torsion. Okay, you know all these things. So you need to first see whether the torsion that is coming in the beam is compatibility torsion or equilibrium torsion. If it's a case of compatibility torsion, then you can assign torsional modifiers, but you have to be careful. And then if you are assigning modifiers, torsion modifiers, it's a it's a potential pitfall, because then you will have to also ensure that detailing is provided in that manner. Okay, so generally for peripheral beams you could do this, not for continuous beams. Don't do it for continuous beams. For peripheral beams you do it, that you assign torsional modifiers if that is the case. Okay, so long answer short, if I wanted to tell you, if your beams are failing in torsion, you need to judge first as a structural engineer what is the reason for this torsion failure, uh, what nature of torsion it is, and then you assign the torsion modifiers. Mr. Rohit Patel is saying, or if I connect this beam to column which marked in sky blue beam getting passed, maybe due to major axis. See, major axis moment of column. Now, so you investigate this. I didn't understand this comment properly, what you wrote next. But you investigate these things that I just said. First do that and then take that call. Yes, Bhushan sir is also joining. Thank you, sir, for joining. He's saying L effective equal to God. Okay, so he was, I think, commenting on the earlier explanation. Correct. So L effective equal to God spacing. So he's saying that about the major axis also, you take the L effective as God spacing. Yeah, I just said that it's a design call that can be taken. For GUTs particularly, you could do that. But then because the GUT columns are not going to be different from internal columns, I would still continue to take the LZ as the full column height. And sir is telling tie beam levels is it correct? L effective equal to minor direction. Yes. So okay. So what he is saying is that suppose sometimes what happens also. So let's put it this way, that let's say I have an internal row of columns also. Okay. So suppose my structure was like this, and I had an internal row of column also. Now in this case, because this is an internal column, there will be no, let's say, GUT. There's going to be no GUT. But suppose at this level, I'm going to provide a tie beam, which is also called as a surge girder. So I'm going to provide a surge girder over here, and that surge girder is, let's say, at whatever, 7 meters on the ground where you had your crane bracket. So in this case, I can take this Ly as 7 meters because of the presence of surge girder at that level. Here I will not take Ly as 1.5 meters because I don't have any guts over here. And then Lz I can continue to take as full 15 meters. So maybe you could do this for internal columns. Mr. Chinmay is continuing with his first question that he had asked about the FSC calculation in this thing. So he's saying if we use the formula given in SP16, strain is equal to this. Yeah, that's what I'm saying. You don't know the XU max upon D ratio over there. That ratio calculation of XU max upon D, if you don't know, you will be unable to calculate it. Right? Because you are in doubly reinforced. So your XU has reached that XU max level. So you need that XU max upon D ratio in order to calculate the FSC and use similar triangles. That is the problem. So if you are not able to use, if you don't have the XU max upon D, then you will have to go with the first principles. That means for your provided reinforcement arrangement, you do the C equal to T calculation and then find out the stress strain curve and then proceed. For this, you can refer that Pillai Menon book where they have solved a few examples using the first principles of stress strain compatibility. Yes. Anything else? Oh, so Engineer Dinesh, he is joining us from somewhere in India because he has just written India in the place. So he is saying, very interesting. When beam failed in shear, some consultants provide shear plate for beam. How to design and provide such shear plates? So he's asking, suppose I draw an elevation of the beam. Okay, this is an elevation. This is my span of the beam. This is column. This is column above, column below. This is beam. So beam is failing in shear, stirrups are failing in shear. So some consultants provide the plates. We also have done some projects where we did provide the shear plates. So what we have done, I'll just tell you. So we provided plates like this, just like stirrups. Okay. And in the sectional view, they looked something like this. So if I were to draw a section, they looked something like this. Uh, how will they look? So this is my beam and shear plate like this. Of course, this was not the only thing that we did. We had to tie it with the existing reinforcement and a lot of other things we did. We also drilled some holes like this to ensure the proper bond transfer in shear. So he's saying when beam fails in shear, some consultants provide shear plate for beam, how to design and provide such shear plates. So what we had done was, and it was sort of a jugaad thing that we had done. So we continued to use the same principle that your V, what is that formula? V S equal to 0.87 Fy ASV D upon SV, isn't it? So the shear provided by stirrups is this, correct? Shear provided by stirrups is this. So now this is what we did. Okay, I am not saying whether it was how correct the methodology was, but I think it was a decent job. It was a decent calculation. So we continued to take the same thing, and then over here the ASV that we took was the combined cross sectional area of this two plates because plates will be on either side. I hope you understand this. This is section AA. So ASV was this, D was the depth of this beam, effective depth, SV was the center to center spacing we were going to provide between these stirrups, not shear plates. Okay. So the important thing over here is how to ensure that the proper shear force transfer takes place from this concrete core to these shear plates. So we had actually chipped the concrete, we had chipped the cover concrete, we had exposed the cover concrete, and then on those existing stirrups, we had joined these plates, and then we had also provided through bolts, and then those shear stirrups, sorry, these shear plates were further joined with the longitudinal bars also by further arrangement so as to ensure proper shear transfer. But then this is what we did by adding these shear plates. Mr. Chinmay is saying, is it safe to provide such shear plates? So this is what we did, okay. Is it safe to provide such shear plates when shear stress is larger than tau c max? Technically, if tau v is greater than tau c max, what you can do is you forget the concrete and just ensure that enough of shear plates are there to take the complete view. This is one approach you could do, but of course I'm not suggesting that if your shear stresses go beyond tau c max, you could just rely on the shear plates, because if that concrete is failing, you need to also ensure proper uh, shear transfer. So even though concrete is failing, it still has to transfer the forces to the shear plates. So I would not suggest that if your tau c max or tau v is exceeding tau c max, you should do this thing. That criteria should still be satisfied. Okay, this is my opinion. Very good. Mr. Chinmay is asking, can we increase the shear capacity in beam with the enhanced shear capacity formula? Yeah, you could do that, but then there are some riders, and there are these riders that if you are doing this, then the shear force has to be taken at that face only. That means you have to take the shear at the face of support. Generally we take the reduced shear at d distance, so then that you will not be able to do. And then if you are doing the shear enhancement, and I'll just take a screenshot, if you are doing that, then this shear reinforcement also needs to be provided as given in the code. So if you can read the screenshot, you need to ensure that this shear reinforcement is provided if required, and also you cannot take that shear at d distance away from the support. Then you have to take the shear at face. Okay. Yes. Anything else? Let me just check any messages on WhatsApp. Uh, oh, very good. Very good question. Let me take up this question. Engineer Ravi Chandra Veluri is asking. He is a quite an inquisitive engineer, I must say, and he has a lot of deep insights. He is a practicing engineer in from Bengaluru, and he is asking this question. Yeah, so he is asking. Suppose I have an L-shaped shear wall. Suppose I have an L-shaped shear wall. So what sort of pier level arrangement should I give? Should I give it as P1, P2, two legs, two different pier arrangement, or a same no, pier label? Sorry. So his question is, should I give a same pier label like P1, or should I give different pier labels P1, P2? So my answer is what I have also discussed this before, that my suggestion would be that you first see what are the first check the actual stress level in these walls. Okay, If the axial stress level is same, if the axial stress level is same, just give me a minute. What I'll do is I'll just invite him also. So I was saying if the axial stress level is similar, then what will happen for similar axial stress levels? You will get a similar PM curve, isn't it? So in such a case, if axial stress levels are same in these both legs, if you sort of know this, that you are going to get a similar PM curve, then you could give one peer label to this L-shaped wall. Okay. If not, it is always better, because what is happening in ETABS software, when you give this one peer label to both the legs, what it is going to do, that it will take combined section properties and it will find out a combined PM interaction curve, and in that combined PM interaction curve it will algebraically add up the axial forces and do the algebraic uh, what should I say, do the algebraic or find out the equivalent moments. So in this case, if you are giving a single peer label, it is going to treat it as a combined section and then do the calculations. Now this approach is risky if the actual stress levels are different in these two different legs. So this approach should not be adopted, and I would say it is always better to go with two different peer labels. In that, you are assured that even if the actual stress levels are different, these two legs will be designed and reinforcements will be provided separately by the software. Then you can take that call that suppose the PT, let's say, is 0.8%, and over here the PT only came out to be 0.45%, suppose. Then you can take a call whether to provide in both the legs the higher reinforcement or to provide two different reinforcement percentages in two legs. That call you can take, but when it comes to peer level assignment, I will always suggest you to go with different peer level assignments to different legs. Don't give a common peer label. And this I am saying because we will not be able to judge the actual stress levels in every load combination. I would say better to go with different peer labels. Okay, good. Anything else? Any other doubt? No. So I think we have taken all the doubts from the Google form, and we have also taken the doubts from the live comments. We have also taken doubts which were asked just now on the WhatsApp messages. So I guess there is no further doubt that has been asked. So in case there is no further doubt, we can end this live stream now. See this Google form that is there is a constant link. That means that link is the same link for the Google form every time. So in any of, you don't have to wait to post your queries on the day when we are conducting the live session. You can keep on putting those queries and we will take them up when we do this live session. But what I'm saying, you can continue to put the queries. You don't have to wait for the live sessions to come and then put ask your queries. So I'm just showing this link that I've just put in the comment section, live comments. So you can just take the link from there. In the video description also, this Google form link is there. So you can just go on putting your questions. We take them once every week, but nobody is stopping you from putting the questions over there. Okay. Yes. So anything else? No questions. So then that's it for this week. Thank you and have a good weekend. And we will see you next week now. Till then, have a good week ahead. Bye bye. Thank you. Oh, there is some question, I guess. No, no. That's it then. Thank you. Bye bye.